Welcome again to Finite Acceptor lectures part 2. In this video lecture, we will discuss about removal of lambda transition. So let's first see what is lambda transition. In this example, we can see there is a transition between the state Q0 and Q1, and also there is a lambda transition which is Q1 and Q2. Mostly we already know what is lambda transition is. That is when a state transit from one to another without taking any input symbol, that is marked as lambda transition. And for different conversion like generating regular expression or converting NFA to DFA, we have to remove this such type of transition first. So let's begin with removing lambda transition from any NFA design. Actually, there are two ways we can remove lambda transition. The first method is as follows. Suppose there are two states, V1 and V2. Suppose there are two states, V1 and V2. So we have to find all the edges coming out of V2. Suppose some edge coming out of like A. So V2 has edge which is coming out of V2 with symbol A. From V1 we have to, suppose there is lambda transition here, and I have to remove this lambda transition. So I have to copy this edge from V1. Suppose it is going to some XQ. So we have to copy this edge with label A. Now initially it is initial state. Okay, I think it is a final state. If V1 is initial state, then V2 again initial state. So let's symbol it like this. Okay. Now if V2 is final state, so V1 is also final state. And in this case, this transition will be removed. So these are basic steps. Let's go to the example. So you can see that here there are three states, Q0, Q1 and Q2, and Q1 is the initial state and Q2 is the final state. Okay, so there is a transition with 0 input symbol to Q0 itself, and lambda transition from Q0 to Q1, 1 Q from Q1 to itself, and lambda transition from Q1 to Q2, and 2. Okay, so I have to remove these two lambda transition. So following the previous instructions, in here you can see, suppose Q0 is V1 and Q1 equal to V2. So there transition should come out from Q0, which is also coming out of Q1. So in this example you can see that there is a transition with label 1 from Q0 to Q1. So Q1 to Q0, there is a transition with one symbol. And again, there's a lambda transition coming out of Q1, which is Q1 to Q2. So again, there is a lambda transition with Q0 to Q2. So again, we have to remove, and since Q0 is initial state, Q1 is also initial state. The next step, now suppose we have to remove this lambda transition from Q0 to Q2. So again, there is a transition coming out of Q2 is 2. So we have to copy this symbol, and Q2 is a final state to Q1 is also final state. So last, this transition, lambda transition is left. So you have to remove it again. Again, you have to follow this transition that Q2 to Q2 should symbol 2. So we have to copy this edge from Q1 to Q2 as well. So you can see there this transition with input 2. And again, since this is initial state, this is also initial state, and this is a final state, this also becomes final state. So this is a final NFA after removing lambda transition. So this is a method 1. The next method, which is also useful in the in conversion of NFA to DFA, since not only lambda transition removed in this method, also we can reduce the number of unnecessary states. So for that, we have to understand important operation which is called lambda closure. So what is all about like that? If we start with the state, suppose A and there is a transition with lambda. Suppose there are a couple of lambda B and then C. So we follow from every transition with lambda from A to C. So all these states, and suppose we want to find the lambda closure of A, then all the states in this path with the same level, which is reachable from A, will be part of this lambda closure. So lambda closure of A will include all the states A, B and C. So this is the way we can find out the lambda closure of any state. Let's have a look at this second example where there are 7 states starting from Q0. This is the initial state. And we can see that there are a number of lambda transitions starting from Q0, and there are another non-lambda transition like A between Q3 to Q4 and with symbol B with Q4 to Q5. Suppose we have to find out that the lambda closure of Q0. So start with Q0 and find the closest lambda transition. Suppose this and this. So first we have Q0, Q1 and Q3. Then again among these states we have Q1 have transition from up to Q2 with lambda transition, so include Q2 here. Then again there is a lambda transition from Q2 to Q5, so also include Q5. So this is the final lambda closure output of Q0, state Q0. So this operation is very useful in method 2 for removal of lambda transition. So let's have a look at method 2. We always start with the initial state Q0 and we find a lambda closure Q0. So whatever state we are getting after lambda closure Q0, that will become the initial state of the reduced or removed lambda transition based NFA. Suppose there we get k number of states starting from P1, P2, Pk. Then we have to find if there is a possible transition from any of these states, suppose Pi, with non-lambda transition. Suppose A may be any arbitrary symbol from the input symbol sigma set. So this is can become, so A belongs to this set. Let after getting this input, we can reach m states from the Pi. Let's mark this as R1 to Rm. Okay. So in the next step, we have to find again lambda closure, which is accessible from any of these states. Then again repeat this whole 3 steps again until unless we exhaust all the lambda transitions. So for this example, how can I find the equivalent NFA without lambda transition? We start with Q0. So here we already obtained this state. This state will become, this collection will become initial state of the equivalent NFA. So we obtain the lambda closure of here. So this, suppose we represent this set with A. Now we have to find any path is possible for its symbol A. So because in this example we have two non-lambda transition like A and B. So to find A, so there is a path from Q3 to Q4. So we get Q4 for input C. There is no path possible from state A with symbol B, so it is empty. So the next step we have to find lambda closure of all the obtained states. So we have only Q4, so we have to find lambda closure of Q4. Lambda closure Q4 is only includes Q4 and Q6. So we get Q4 and Q6. So again we represent this set with B, and again we have to find any transition which is possible or not with the symbol A and B. There is no possible symbol transition with symbol A, so this is empty, and there's only one state reachable from set B, which is Q5. So after we also always take this representation as a final state symbol. So after removing all the lambda transition, we get this final transition diagram. We can see here important point about this diagram is that it not only the lambda transition is removed in this NFA, we also get a reduced form of NFA.